Welcome to this Oracle Database World session, eliminating risk when migrating and implementing changes. My name is Björn Boltoft. I'm Consulting Product Manager for Enterprise Manager. Please read the Safe Harbor statement. The agenda for today is database migration and upgrade challenges, key use cases and Oracle solutions, resources and next step. As a database administrator, there are challenges every day, like when you changing in a Totora parameter or when you upgrading the optimizer statistics. And the question you ask is, will that change the performance in some way? In the same way, when you're upgrading your database, you also want to find out if there are any regress sequels or plan changes. Or there could also be throughput changes, like sequels taking longer time, there are more weights, or there will be new weights introduced, or other errors as well. There are situations when it's difficult to understand the regression, like you have not changed anything in the database, but you still have performance regression. There are also situations when you want to migrate your database and want to know the best strategy for doing the migration. Or you want to migrate or consolidate databases to a new platform and want to know the capacity needed. Real application testing has a rich set of features that will help you in the complete life cycle of the database. So we start with Spark Quick Check. This is the tool that will help you with the routine task. It will identify the sequels that are regressing if you change in a Totora parameter or if you changing optimizer statistic. We have SQL Performance Analyzer. This is a SQL unit response testing. It will execute the sequels before change and after change and will compare the statistic, identify sequels with new execution plans and sequels with regressed execution statistic. We have Database Replay, that is a load testing tool. We record the production workload and replay it in test environment with the same concurrency and timing as in the production database. It can identify concurrency issues and errors caused by bugs in new database versions. We have a few new features. Workload Analysis. It's reactively identifying the impact and root cause of workload changes. So you can identify the changes between yesterday's and today's workload. We have Database Migration Workbench. It's a tool that helps you to optimize your migration strategy. It will execute the migration of your database and you will be able to monitor the workflow. We have the Database Migration Planner. It's a tool that helps you to simulate migration and consolidation and provide you with the capacity planning of increased workload. Altogether, these tools will help you to automate the testing, lower the risks, and cut the cost of your database administration. Let's take a look at a scenario that's not too uncommon. How do I ensure performance after a combined platform change and an application upgrade? So I have outgrown my capacity and my application needs to be upgraded. I don't have several windows, I just have one window to do both the migration and the application upgrade. So how do I ensure new platform can handle always increasing need of capacity? And how do I ensure that the new application doesn't introduce regression? So for this, we will use 3 different features of real application testing. First, we're going to use Migration Planner to analyze the capacity and simulate the growing capacity. Then we're going to use Database Migration Workbench. That will help us to identify the optimal migration strategy, and we will also be able to migrate the database with this feature. And the last feature that we're going to use is Workload Analysis. This will help us to identify the changes that have been introduced with the new application version. We will be able to see if there are any regression due to plan changes. There could be new indexes implemented. We will also see if there are new SQL statements or missing SQLs. Let's start with the short introduction of Database Migration Planner, and then it will follow with a demo of the product. Database Migration Planner helps you with analyzing the capacity required for the new platform. You can analyze the capacity needed for migrating and consolidating database to the new platform. New platform can be cloud platform like Exadata Cloud at Customer, Exadata Cloud Service, or it can be on-premise, either Exadata platform or a commodity platform. It will help you to analyze the capacity required to meet your required capacity. There are two steps in the workflow. First, we create migration project, and then we will create different migration scenarios. In the migration project, we first select the source databases that should be included in the analyze. For these databases, we collect the workload statistic. This includes AWR statistic for the databases. We got the spec metric for the host, so we can do a complete analysis of resources used and resources needed for the new platform. We do a coarse grain analysis, and we will provide information about the resources needed and findings like ADDM findings from the database. Next step is creating migration scenarios. In the migration scenario, we can exclude databases. We can change the utilization, like increasing workload, or we can calculate with different resource allocations, such as using the hourly average or the hourly peak as an example. We can also add resource constraint. A constraint is that a database cannot share the same hardware as another database if they, for example, is a primary and a standby database. We will also provide destination selection. A destination can be an Exadata target, a cloud service, or it can also be an on-prem database already discovered in the Enterprise Manager. Then we perform the analyze, where we do the calculation of the resource needed and the resource used hourly by hourly. That will provide us with resource utilization and a confidence if this migration or consolidation will fit into the new platform. Let's look at a short demo of Database Migration Planner. Database Migration Planner can be accessed from Enterprise, Migration and Consolidation Database Migration Planner. We select Create Project, provide a name for the project, and click Next. Here we select the source databases. We can filter on sales in this case, and select the sales database. We use the default data collection days, and we click Next. We will not use any pre-configured scenarios. We click Next, and now we submit the workflow. It will now start to collect the data for the time range. So in next step, we will create a scenario. We will use an already pre-created project. We create a scenario, provide a scenario name, and here we have the ability to set a scale factor for CPU and memory. In this case, we will use 1.25 for CPU. Scenarios with different resource allocation. We can have ultra conservative, where we using the peak workload hourly by hourly, or We can use a medium scenario where we use the 80% percentile of the hourly usage. So let's use the medium. Click Next. Here we can set the constraints for the scenario where a database are not allowed to be allocated with another database if there are database properties that differs, like lifecycle status, database configurations like database additions, or constraints like data guard, primary standby database. Click Next. Here we allocate the destination candidates. We will use Oracle Cloud Infrastructure, and we will use Exadata Cloud at Customer. We will use an X8 rack with InfiniBand switches. We can also set maximum resource utilization. Click Next. We click Next, and then we submit the scenario. So let's look at some pre-created scenarios. In the year 1, 2, and 3 utilization, we have calculated with a growth of 25% yearly. So let's look at year 1. The source database, sales. The destination is an OC7 server. We can look at the ratio. It will be 1 server, 1 database. Mapping, just 1 database here. Storage, it will tell us about the IOPS, IO bandwidth, and space needed. We will look at the confidence, and what we can see here is that the workload is growing, starting on 30% and will increase to about 55%. We will see there are no violations or exclusions. We will see 3 different advisory findings. The log file write indicates that the log files are too small, and the buffer cache hit ratio indicates that the buffer is too small on the current platform. So let's look at the year 3 utilization. We have same source destination. Now we can see that the utilization will be above 74%. Storage and the confidence. What we can see here is that starting about 45% and the peaks will be over 90%. We will look at the resource type, where we can see that it's the CPU that's going to be the resource constraint. We can also see that there are still no violations or exclusion, and the advisory finding is more or less the same as before. By looking at the Exadata with the utilization same as the 3-year utilization, here we can see that on the database machine with more resource, CPU resource available, then we can look at the confidence on this machine, and we can see that on this Exadata we will be using less than 60% in the top peak. We have now been able to run different scenarios where we can see the utilization, we can see the growth of the utilization, and we can see which platform that will accommodate this workload after 3 years. That will help us to decide if we're going to run a smaller platform in the beginning and do a second migration, or if we will start with a larger platform and be able to stick on the same platform for all 3 years. Workload Analysis. This is a new feature that will be introduced in upcoming release update. So what is Workload Analysis? So in SQL Performance Analyzer, we have the ability to compare two different SQL tuning sets. And this helps us to identify if there are any new SQLs from one of the SQL tuning set that doesn't exist in the second SQL tuning set. We will also see if there are missing SQLs in the second SQL tuning set. We will be able to see change performance on SQLs. So even if there are no planned changes, then we can see if SQL take a longer time to execute. We will see planned changes between same SQL in the two different SQL tuning set, and we can also see if there are increased workload by more executions. With SQL Performance Analyzer, we also have the ability to use SQL profile or SQL plan baselines. Of course, for new SQLs, there are no possibility to use SQL plan baselines, but we can still use SQL profiles in that case. So we have 3 different workflows in workload analysis. We have the one-time analysis. So here we have the pre-change SQL tuning set, then we do some change in the database, and then we use the post-change SQL tuning set. So we capture SQL tuning set from 2 different time periods. It is more when we have application upgrades. We do the analyze, we have the reporting, and we tune and remedy the SQL if necessary. Rolling baseline. With rolling baseline, we capture SQL tuning set as a baseline SQL tuning set, day 0. Day 1, we compare this baseline with day 1 SQL tuning set, do comparison, and have the ability to analyze and report and see if there are any changes. Then we're using day 1 SQL tuning set as the baseline when we're comparing with day 2. With a fixed baseline, we're using the baseline SQL tuning set and always comparing with the same SQL tuning set. So it's day 1 and day 2 and onwards. This will help us to identify the SQLs that slowly regressing in performance due to more data in the database. With the rolling baseline, we mostly compare and trying to identify if there are any changes day to day. So the workflow for this is we capture this baseline SQL tuning set for the interesting workloads. So that could be several SQL tuning sets for different workloads, like the night batch, the daily activity, or the weekend activity, and so on. We compare with the corresponding period with this new SQL tuning set, and we get the execution statistic for the SQLs. With no regression, then we are satisfied and can continue with the daily activity. If there are regression, then we can use SQL Tuning Advisor and SQL Plan baselines to fix the regression. Of course, we should always use SQL Performance Analysis Spark Quick Check to do the analyze. If there's still regression, then we need to go and do another iteration. Otherwise, we implement the changes, and we are now ready for the next day. So with the one-time analysis, it's semi-automated because we capture the SQL tuning set and we decide when we do it. And after that, everything is wizard driven. So tell the wizard which SQL tuning set to use and do the comparison. It can help us with application upgrades, or if there is someone that changed an DORA parameter, adding new indexes and didn't do the testing. As we said, it's also regression can be fixed by using SQL profiles or SQL plan baselines. So let's look at the report. In the workload impact comparison section, we will see the overall performance, if it's regression or improvement. We will also be able to see how much improvement, regression. We will be able to see missing SQLs and new SQLs. And then we have everything broken down on the SQL by itself. So by clicking on improvement, regression, and unchanged SQL, we will get another view that's only showing these SQLs. We will also see which SQLs that had plan changes. So let's do a demo on this report. This is the Workload Analyzer report. It's an active report and we can drill down on details. We can see that the execution time before was higher than after. We have improved SQLs, we have regress SQLs, and by clicking on the regress SQLs, we can go to details and see all the regress SQLs. We're selecting one of the SQLs. We can see the details on the SQLs. We can see that elapsed time has increased, CPU time has increased, and buffer gets has increased. And we can see the amount of time or buffers it has increased with. We can see the findings that it's just a performance problem on this SQL. So let's look at the SQLs with new plans. Here we can see that we have both increased and regressed performance on SQLs. Let's choose a SQL with regress plan. Here also elapsed time, CPU time, and buffer gets increased, even cost and reads has increased. And we can see two different problems. It's the performance and the symptom is execution plan has changed on the SQL. We have the ability to drill down on the plan so we can see the before and the after plan. We can look at the SQL text, we can see the SQL information, and we can see the bind variables on this execution. Let's go back. We can also look at the missing SQL. As we see, all missing SQL is improvements and all regressed SQL will be regression. This finalized the demo of Workload Analyzer report. Another feature that was introduced in Enterprise Manager 13.5 was the Database Migration Workbench. The Database Migration Workbench is a tool that helps you with planning of your migration. You select the databases to migrate, and it will use a guided wizard for the migration. It analyzes the schema before the migration and identify if there are any problems to use a special method. It will perform the migration, so you can customize, schedule, and do the rollback of your migration. You can also pause and resume and monitor the progress of the migration. You have integration with Oracle best practices for migrating a database, and you will also have integration with third-party tools using APIs. In the end of the migration, we will perform a SQL performance analyzer execution and validate the performance after the migration. So the workflow for Database Migration Workbench is create migration. You can customize the migration. It will analyze the source. Then it will schedule and submit the migration. And during the migration, you have the ability to view the migration details. It will analyze the data transfer and it will compare the performance. And after, you will also get the cleanup and the workflow will be marked as completed. We have support for several amount of databases from 11.204 until 19c. We have the ability to migrate single databases, rack databases, and multi-tenant databases. The destination databases can be databases with transparent data encryption. It could be on Exadata, rack. It can be on Exadata Cloud, Cloud at Customer, and Exadata Cloud Services. We also can migrate single instance database to multi-tenant database, and we have the ability to both use OCI and autonomous database. We have support for several migration methods as well: data pump, transportable tablespace, plug and unplug a database, and using standby databases. Target platforms can be Linux, AIX, Oracle Solaris, and Windows. So from Enterprise Manager, you will have the dashboard that shows you the validation, export, and import. And here we can see that in the import we can see that there are a few errors, and it's on the sales schema. And you can see that some of the objects already exist in the database, and there are also primary key violations. So for all the steps, we have the drill down to analyze the migration, and we can see which objects succeeds or fails. We will get the error message for deep insight and reasons for failing objects. So as a summary, real application testing and all its features, improving the business agility through faster and risk-free adoption of new technology. You can use it for database upgrades, migrating to Exadatas, Exacloud at Customer, and Exacloud services. Real application testing is also a proactive tool that identifies and fixes performance problems before they occur on production system, whether it's on cloud or on-premise. We also have the ability to use reactive analysis to identify and fix performance problems on production system. The key benefit of using real application testing is increased DBA productivity, increased availability and uptime of business applications, and there is a strong return of investment. An Oracle internal evaluation showed that the return of investment is 224% over 3 years, 5.9-month payback period, risk adjusted. Thank you for listening to this session. If you want more information, you can go to oracle.com. We have video by example, and we have different blogs. Here is DBA Heroes Validate. The real application testing documentation can be found in the testing guide. For Oracle Cloud Free tier, there is a possibility to use Always Free service that can be used for unlimited time. Plus, you have the 30-day free trial, free credits you can use for more services.